Alright, in this video, I'm going to be talking about binomial coefficient review. This is for CS140, specifically the Kino lab. You'll be doing stuff with binomials. So, binomial coefficients are also known informally as n choose k, also known as number of combinations. So the formula for the binomial coefficient is n factorial divided by k factorial times n minus k factorial. If you need a factorial review, check out the other video on this YouTube channel. So what does this really mean? This is the way to calculate the number of combinations when you have n distinct types and you're choosing k items. So I know that sounds a little mathy, and the best way to kind of understand this is with an example that you can easily count the number of combinations yourself by writing it out, and then see how the math matches up. So let's say we have a basket, and in this basket we have 4 different balls, and the balls are colored distinctly, so we'll have n distinct types. So we have a red ball and a green ball and a blue ball and an orange ball. So we have 4 distinct balls. By distinct, I mean that we can tell the difference between each ball because they're a different color. And let's say I want to see how many combinations I can create when I choose 3 balls from this basket. So if we're just doing this conceptually and not thinking about the math, it's easy to see that there's 4 combinations because I'll just see, okay, I'll choose 3, leave 1 out. And we can be like, oh, well, I can leave the orange out, and then I can leave the blue out and have a combo of 3, and I can leave the green out and have a combo of 3, and leave the red out and have a combo of 3. So it's kind of easy to write this one out by hand. So let's say these circles represent my handful that I will hold my combo in. So I could have the red and the green and the blue together and leave the orange out. And then I could have the red and the green and the orange and leave the blue out. And then I could have the red and the blue and the orange, so I'm leaving the green out. And then I could have the green and the blue and orange, so I'm leaving the red ball out. And that's all the different combinations I can make. You can see here that the order doesn't matter. I'm just acting as if they're a handful of balls. I don't care that the green is before the blue or the orange. There is no conceptual formation of order here. So that's important to realize. And I can see I have 4. So how does that match up with this formula where I have n equals 4, I have 4 distinct balls, and I'm choosing k items, I'm choosing 3. So k is equal to 3. And 4 minus 3. Factorial. So what is this equal to if I actually write out the multiplication? 4 times 3 times 2 times 1. 3 times 2 times 1. This is equal to 1, right? So just another times 1. So this is going to cancel out with this. And I'm left with 4 divided by 1, which of course is equal to 4. So just my little check by hand is right. I would have 4 different ways of making combinations. So obviously, as you have more distinct balls and your choose number is different, it's going to be hard to do this by hand. So this formula is very, very useful in counting the number of combinations. Again, this is for CS140, the Kino lab, a review on the binomial coefficient.